All right. Okay. So before we start, we have to pray. So let's pray. Our Heavenly Father, thank you so much for such an opportunity to meet again. As you're about to meet, we pray that you will guide our understanding. And Father, we ask that whatever thing that we will learn here today shall be spirit-led, it shall be led by you. This and many more we ask in Jesus Christ our faith. Amen. Amen. All right. So today we are come to learn about matrices and vectors. So we are come to learn how to create matrices. And matrices are, arrays are for matrices. Yes. So we are come to learn how to create matrices and also how to use them. That's one thing that we are come to learn here today. All right. So as I said yesterday, I said something yesterday that with MATLAB, one thing about MATLAB is that MATLAB does all its executions in matrices form. That's how it does all its executions. Like every single execution is being done in matrix form. Do you get what I'm saying? Okay, so we have to learn. So it's like the basis of MATLAB is matrix. So I mean, if you don't know how to use a matrix, if you don't know how to manipulate your way through matrices, you basically cannot do anything with MATLAB unless the symbolic math aspect. And that's something different which we'll go through. Yeah. So arrays in MATLAB. So most of the times in MATLAB, everything over there is scalar. Do you understand? Everything over there is scalar. It's not really necessary. So in MATLAB, all variables are arrays. Then a scalar is an array with a single element. And then a vector is an array with one row or one column. And then a matrix is an array with what? Rows and what? Columns. As I explained earlier. Arrays are from what? Arrays are from matrices. So when we have a scalar, so a scalar is just an array of a single element. So let me share my MATLAB screen too. So let's say we have, let's say A is equal to 2. Can you see can you guys see my matrix? Can you guys see my MATLAB window?
Yes, boss, we can see.
Okay, so when we have like, let's say A is equal to 2. See, 2 is a single element. So in this case, 2 is a what? 2 is an array. Do you get what I'm saying? Aha. And then the next one says that what? The next one says that a vector is an array of what? One row or one column. So in MATLAB, when we want to write a row or a column, this is how we do it. So in MATLAB, when we want to write a row or a column, so for a row, so I said yesterday that normally when you want to do something in MATLAB and then you don't want it to execute, you want MATLAB to ignore that command, use a percentage sign. So I use a percentage sign. So to write, okay, to compute rows in MATLAB, we have to use what? We have to use the comma or space. So in that case, so B will be equal to, so B is equal to, so when you want to start an array, normally start with a square bracket. So you start with a square bracket. So if you want to compute a row, we start with a square bracket, 2, 3, 4, 5, 6. Then you close the bracket to the number that you want. Then you do what? Enter. So that's a what? So that's a row in MATLAB. Do you understand? Then that same B again. Somebody could also write it with 2, 3, 4, 5, 6. Close the bracket, enter. You see, it's the same thing. Do you get what's going on? Please, do you understand what's going on now? Hello, do we understand what's going on? Oh, okay. Let's continue.
Yes, please, we understand.
All right.
So it means that the main thing is the square bracket, not the comma.
The main thing is the square bracket. Yeah. The square bracket must be there. Do you understand?
Yes, please.
So the next one is also, so to compute columns. So to compute columns in MATLAB. In MATLAB, we have to use the words. We have to use the semicolon. So in that case, C will be equal to what? So C will be equal to 3, semicolon 4, semicolon 5, semicolon 6, semicolon what? 7. Then you close it. Enter. So you see we have a column. So you see we have a what? You see we have a column there. Okay, come, let me move this to the top. Then now, when we want to, there's another way to also compute columns in MATLAB. What do I mean? When you transpose a row, you get a what? You get a column. When you transpose a column, you get a what? You get a row. So somebody might just, me like this, I personally don't like to use the column thing. So what I do is that C is also equal to what? 3, 4, 5, 6, 7. That I create a row. So when I create a row, then I transpose it. So transpose, use the prime. Use the prime. That one is on your what? That one is on your computer. So your keyboard. Use the prime, this one. Enter. You see, we have the what? See, we have 3, 4, 5, 6, and 7. Those who like the comments too. C is equal to 3, 4, 4, 5, 6, 7. Then they use the transpose. Are we fine here? Are we fine here? I want to know if you are fine here. Are we fine here?
Yes.
Yeah.
Okay.
Yes, boss. Yeah,
Yes.
fine.
All right. Thank you. All right. Thank you. Thank you. So let's continue. All right. So then now a matrix is an array with what? Rows and columns. So now let me just show us briefly how to write a matrix. So to write a matrix in MATLAB, we know matrices comprise of what? Rows and columns. Do you understand what I'm saying? So to compute matrices, we know they comprise of what? We know they comprise of row and what? Rows and columns, right? Aha, perfect. So since they comprise of rows and columns, it means that we have to write rows and columns. You get it? So now to write a matrix in MATLAB, what you do is that we write our rules. So like, let's say we want, okay, so let's do it this way. So we have 3 different rules. So let's say we have 3 different rules, like row 1. Okay, so let's call it R1. So R1 is, somebody should give me something. So 2, 3, 4, 5. Then close it. Then let me suppress the outputs. Then R2. R2 is -1, 4, -5, -2. Then I suppress this one too. Then R3, let me put a 3rd row there. So R3 is say 0, 4, 9, -1. Then I suppress it. Good. So now I've gotten 2 rows. I've gotten 3 rows. And of course, like, yeah, I've gotten 3 rows. If I want to put all of them into a matrix, that matrix will be what? Row 1, column, semicolon, sorry. Why semicolon? Because when I put a semicolon there, it means that what is to push the next element to the what? To the next line. Do you get the explanation? When I put the semicolon there, what semicolon does is that what? It pushes the next element to the next line. Do you understand? So you see when we did, so now, so let me use this explanation here. You see when we did 3 semicolon 4, so it means 3, push 4 to the next line, push 5 to the next line, push 6 to the next line, and push 7 to the next line. Do you get it? But then over here, when we do 2, 3, 4, and 5, and 6, it means join them together as a rule. Like make them flow together as a rule. Do you understand what I'm saying? Like just make them flow. But then with the column, what happens? But with the semicolon, what happens is that we'll push them to the next line. Do you get it? So now we are here to compute matrices. It means that this is row 1. They are flowing. Now, when I say, so now I'm putting it in the square bracket. Now I'm like R1 column, R2. So meaning push R2 to the next line. Then push what? R3 also to the next line. Do you understand? Okay. When I do that, I have my matrix. 2, 3, 4, 5, -1, 4, -5, -2. 0, 4, 9, 1, -1. Do you understand what I'm saying? Yes, but then All right. So to the next thing is that somebody will ask me, oh, why didn't I just compute the elements straight away? But then I just wanted you guys to understand how I formed the columns and I formed the rows. That's why I did it this way, so that we can all get it. So now to compute them normally is 2, 3, 4, 5, one row, column, semicolon, meaning that what I want the next one to be what? To be pushed to the next one. -1, 4, -5, -2. Then push it to the next line. 0, 4, 9, -1. Close. Enter. So you see. Do we get it? Do you understand what's going on? Yeah. So that's how we do it.
Yeah.
Okay, that's fine. Thank you very much. So that's how we get the whole matrix. We get a row, something. Somebody be like, okay, so in case I have columns too, how do I transmit them into matrices? So column 1, C1. C1 will be what? So C1, let's see, 2, 3, 4, 5. Transpose, right? Okay. Then C2. C2 is what? C2 is -1, 4, -5, -2. Transpose. Then C3. C3 is what? C3 is 0, 4, 9, -1. Transpose. Or somebody can just be putting the column there. That's also fine. Then now I want matrix. So what will my matrix be? So my matrix in that case will be what? So my matrix will be C1, C2, no. C1, column C2, column C3. Come, hold on. Nah, the other way around. So that's C1, C2, C3, close. So we have that. Do we get it? Do we understand? Okay. So let's
Yes,
continue.
please.
Right. All right. So the next one, creating one-dimensional arrays, as I said earlier. So directing entering of the values. That's a variable name is equal to what? The vector element. So let me go. Okay, let me finish reading this. So row vector, to create a row vector, type a space or comma between the elements inside the brackets. To create a column vector, type a left square bracket and then enter elements with semicolon between them, or press enter after each element. Type the right square bracket after the last element. That's also a way to also do it too. So let me go back to my MATLAB. So you see, I wanted to write my row. I did this. A space or a what? Or a comma. Then I wanted to write my column. I also placed a semicolon there, but I didn't try it for the column part. I didn't try for the enter one. Or you could also do it this way. You could also write it as a row. Then you transpose it. Yeah, that's also a way of doing it. All right. Then the next one. So semester marks. That's also a way, semesters for a column vector. I hope you can see it. So 78, 82, 69, 77, 91, 67. We've done that. Students rank. The next one too is there. Then now, more on the creation of vectors. Okay. So now we are going to learn how to create vectors in a different way. So creating a vector with constant spacing by specifying the first term, the spacing, and the what? And the last term. So in case we want to create a vector with, say, constant spacing, 3, 6, 9, 12, and 15. So meaning that the first term is what? 3. Do you understand? 3 is the first term, right? Good. Then the last term will be what? So let me highlight 3. Let me highlight 3 to be our first term. So 3 is our first term. Our last term is what? Our last term is 15. Do you get it? Are we here? All right. So what's the constant spacing? So constant spacing is like constant difference. So when we want to get a constant difference, 6 minus 3, 3. 9 minus 6, 3. 12 minus 9, 3. So over here, we want to create a vector with what? First term 3. The spacing is also 3. Then the last term is what? The last term is 15. So in that case, when you want to write such a vector, it's just going to be the variable name is equal to M, which is the first term, kill, column, kill, which is the spacing, then what? N. So let's try that in our MATLAB window. All right. All right. So in that case, we want to write. We want to write a what? We want to write an array. So we want to write an array with first term what? So let's say first term 3, then spacing 3, and then last term to be what? Last term 15. Do you understand? Okay. So then in that case, we said we do it this way. So way one way. That'll be what? So we do it this way as the first term 3. You get it? Is to the spacing 3 is to 15. That's how we write it. Then we are done. Enter. So one way is equal to 3, 6, 9, 12, and 15. So this way it saves time. So say you have a long code to write. Then you're not going to write 3, 6, 9, 12, 15. No. Just put the variable name is equal to open brackets first term constant spacing is to what? 15. Do we get it? Aha. So in that case too, I know you can also decide not to add the brackets too. I know it works. Do enter. Yes. So if you don't add the square bracket, you should work 3, 6, 9, 12, and what? 15. I hope we get this part. I hope we get it. All right.
Yeah.
Good. Let's move on.
Okay.
Now the next one. So creating constant. And then one thing. So one thing is that with this kind of vectors, when you don't put the constant spacing, what it does is that it assumes a constant spacing of 1. So let's try that and see. Let's try that and see. When you don't put a constant spacing, it assumes a constant spacing of 1. So one way again, so one way exp is equal to, say, 2 is to 20. I'm telling MATLAB that what? MATLAB, give me 2 to 20, assuming a constant spacing of 1. That's when the spacing is not provided. Enter. So you can see 2, 3, 4, 5, 6, 7, 8, 9 to what? 20. Do you get what's going on? Aha. So this is one way that we can do it. So whatever we, so D is equal to 10 is to, I think there was D is equal to 10 is to minus 2 is to 2. It's a work out. E is equal to 12 is to constant difference 0. The constant difference, you can say constant difference of 1/3 is to 16. So you can see 12, 12.33, 12.67, 13, what, up to 16. Do you get what I'm saying? And then mind you, when the spacing is positive, it means that your last term should be what? Your last term should be greater than your first term. But then when the spacing becomes negative, it means that what? Your last term is going to be what? Less than your first term, meaning that this time the spacing is what? Meaning I'm moving from 12, then I'm decreasing. I'm going down to my last term. Do you understand? That's if the spacing is negative. But once the spacing is positive, it means that what? It means that there's going to be some ascension. But then when the spacing is negative, there's going to be a what? There's going to be a descension. Do you understand? Okay. So let's continue. All right. So these are various examples. So yeah, square brackets are optional. Then the next one, creating a vector with constant spacing by specifying the first term and the last term and the number of what? Terms. So like, let's say when we have a vector and then we have the number of terms of the vector, we have the first term, we have the last term, and then we are supposed to do what? And then we are supposed to find a vector for it. What we do is that we use the linspace command. This command out here. It's called the what? It's called the linspace command. Linspace. Yeah, with MATLAB, you learn a lot of Every day you are learning something new. Every day you are learning something new. So, so that's the thing. So it's called the what? It's called the linspace command. The linspace command. That's what you use. So for the xi is the first element, xf is the last element, and then n is the what? N is the number of terms that you want. You understand? So when the number of terms is omitted, when number of terms is omitted, the default is what? The default is 100. So if you don't put n there, it means that it's just, okay, n is what? 100, based on the program written by MathWorks for MATLAB. So now let's try the linspace one. So for linspace, f is equal to linspace, say I have my first term to be 2, I have my last term to be 5, and I want 20 terms. Enter.
Bluey,
Yes.
you are not seeing what you are doing.
You're not seeing what
the
I'm.
slide.
Are you seeing? Wait. Are you seeing the? Wait. Are you seeing my MATLAB screen?
No.
You can't see my MATLAB screen.
No.
Oh.
Yeah, we are seeing the slide.
Oh, sorry. Oh, all along I was doing something on the MATLAB screen, crowd. Hey, okay. Then you let me share the MATLAB screen again. Let me share that one. But can you guys see the screen now?
Yeah.
Yeah, you can see the screen now. You can see it now. Okay. So now, oh, so you guys didn't see when I did all these things, like one way.
Oh,
trace,
no. It's just the last part.
just
The
12 is,
the,
or the very one that I
line
started with.
space.
The linspace
Yeah,
one.
just
Yeah.
yeah.
Okay, all right, thank you. So now I'm talking about, I'm saying when I have, like, let's see, when I have my first term, I have my last term, and I have a number of terms. Then let's say I want to write an array for that. You know, of course, you have to now use your calculator or something. But then this one, MATLAB has just provided with the function, has provided with the command that can do that. So in that case, so I've used E already. So F, so my variable is called, so let's name my variable one way 2. So one way 2 will be equal to what? Linspace. My first term is what? 2. My last term is what? 5. I want how many terms? I want 7 terms. Enter. So it gives me 2, 2.5, 3, 3.5, 4, 4.5, and what? 5. Great. So let's try another way. One way 2. Can somebody tell me a first term, last term, and then the number of terms? Then we'll create a vector for that. Anybody at all?
3, 20, 10. First
3,
term 3, second, yeah.
Second term
3, 20, 10.
Then the number of terms 10.
Yeah.
So as you can see, so 3, 4.889, 6.778, 8.6667, 10, 12, 14, 16, 18, and what? 20. So now when you don't put the number of terms there, we say MATLAB assumes it to be what? Assumes it to be 100. Do we understand? MATLAB assumes it to be what? 100. So 3.20. Just close the bracket. Oh, 3.20. Close the bracket. So you can see 100 terms. So everything is here. Everything is here. And also one thing.
Bruce.
Yes.
Please, the middle value represents what?
What?
The first value is the start value, right?
The first value is the start value.
Okay, and the middle one?
The middle one is the last term. And then the last one in the linspace one represents the number of terms that you want. Do you get it?
The number
of
terms. Okay.
Yeah, and I'm saying that in this case,
okay,
when you don't put the number of terms there, it assumes a number of terms of 100. Then it will do that for you. Do you understand?
Okay. How about the interval?
How about the interval? For the interval one, the interval one is a different way. So the interval one is this way. The one that we'll use 3 is to 15. Whereby the middle one is the interval, then the first, and the last. All right. So I hope we are all here. So with a linspace too, you can use a linspace. That's one variety about a linspace. What linspace does is that, so 3 to 2, I want 5 terms. My last term is 2. to give you the terms. It's not limited. Do you get what I'm saying? Okay. Next one. So over here, 6 elements to be created between 1 and 12. So 1 is the first term, 12 is the last term, and then 6 is the number of elements, the number of terms. So lane space 0, 3 pi. 3 pi should be my last term, 6 elements. Okay. Then now, the next one is addressing vectors. Addressing vectors. So elements in vectors, they can be addressed individually, or they can be addressed in groups. You understand? So also, why we do this thing is because we are doing this thing because we'll use them in some calculations. And then you need, like, let's say a particular row, and let's say it's a 10 by 10 matrix. Are you now coming to look through to now pick the row or something? No, there's just a way. There's the question. I'm coming. So there's a way that you can just pick a row, or you can just say, I want to pick this row. I want to pick this particular element. I want to pick, like, let's say row 4, column 5 or something. Or I just want row 5, or I just want this element. So this is what we are coming to learn here. And Maxwell, please, you can ask your question now. Maxwell.
Please, I wanted to know if you can create like a sequence of indefinite spacing.
Indefinite.
You see those?
Yeah, go on. You see those? Hello, go on.
Yes.
Hey, your line is breaking. No. Oh, your line is breaking. No. If you could, please, can we hear him? I think we can't hear him, right?
Yeah, we can.
We can't hear you. So if we could ask, so we could hear you. I want to know what you're talking about. All right. So when he comes back, they will continue. So we can ask that question later. So now, the address of an element in a vector is its position in the row or column. So say for a vector named vein, so vein of K refers to the element in what position K. All right. So let's try that. Can you guys see my screen? Or you are still seeing the slide?
Yeah, the slide.
We are still seeing the slide.
All right. Can you see the screen now? Can you guys see the MATLAB, this one?
Nope.
You
Oh,
can
yeah,
still
we can see it now.
Yeah, we can see it now.
Can see that. All right, that's fine. All right. So now we are supposed to learn something. So let's say, let me go and pick these vectors again. Some vectors that we used already. Okay, so let me add, okay, let me create a new vector. Create a new vector. So vector name day2. So that vector is, let's say I want, okay, 3 is to negative 0.2 is to end at, no, 0.2 is 2 nines, 0.35, and that my last term should be 1.25. Great. So I have this. So I have 3, 6.25, 6.23, 1.95, 1.6, that. So now what we are saying is that, so now we are come to use this one. We are come to address some elements from this particular vector, from this particular row, or from this particular row. All right. So now, then when I have A of 4 is 23. So A of 4 here means that pick the 4th term in the matrix A. I hope you can see the slide. So pick the 4th term from the matrix E. So we are telling MATLAB that MATLAB pick the 4th term. So MATLAB pick the 4th term. Pick the 4th term from the matrix what? E. So in that matrix, the matrix is 35, 46, 78, 23. So the 4th term will be what? 23. Then A of 7. Pick the 7th term. The 7th term, I think, is 81. Pick the first term. The first term is what? 35. Do we get it? Okay. So let's try that. Let's try that too. All right. So now I'm supposed to, let me say, pick the fifth term. So fifth term is equal to what? Is equal to day 2 into bracket what? Address 5. Do you get it? So you see, the fifth term is what? 1.6000. So pick the second term. So the second term is equal to what? Day 2, open bracket what? 2. So 2 point what? 2.65000. Do we get it? Do we understand? Aha. And then also somebody might ask, oh, when you want to, let's say you want to pick from, let's say from the second term to like the fifth term, how do you do that? So in that case, so second to fifth. So second underscore fifth. That's from second to fifth. So that will be day 2, open bracket, from the second term to the what? To the fifth term. Do you get it? Where the 2 there is what? Column. So you're telling MATLAB that, okay, MATLAB, give me from second term to fifth term. Do you understand? So enter. So you see, in that case, we have what? 2.65, 2.30, 2.195, and then 1.160. Now, from what we've learned, somebody who is very, very adventurous could also say that, oh, second to what? Fifth. Somebody who is IRED, who has forgotten this one, can just do this. Open bracket, day 2, open bracket, what? 2. Day 2, open bracket, what? 3. Day what? 2, open bracket, what? 4. That, I mean, somebody who is very IRED can do this if the person has just forgotten the command and it's an exam. Enter. You see, the same thing came out. So meaning address the second term for me, address the third term, address the fourth term, and then what? Address the fifth term. So the compressed form of all this is what is day 2, open bracket, what? 2 to what? To 5. Please, do we understand what's going on here? Do we get it?
Yeah.
Yes, boss.
Yeah.
We get it.
We understand. Okay, let's move on. So refers to the elements m through n of what? Vector what? A. So 5 is to 8. That's 5, 14, 81, and what? 3. So that's the fifth term to the what? To the eighth term. So A is to refers to all elements of the vector A, either what? Row or what? Column. Okay. So I hope we can move on from it. So that's what we use that for. So as I said earlier, an IRED person can do this. Somebody who is very IRED can do this. So you see, when you don't put it in a square bracket, it just gives you the answers differently. That's if you are forgetting that, oh, I'm supposed to call, if you are forgetting I'm supposed to call, like, let's say, okay, no, so this is actually different. We are not calling 2, we are just calling 2 and 5. So in the case where we are calling 2 and 5, AA2 from the diagram, AA2 and then what? AA5. In that case, it's just what? 2 and what? 5. 2 and 34. 3 and 34, sorry. The second term is 3. The second term is what? 34 over here. Aha. All right. So now AA3 is to 6. That's what? 20. That's call from what? The third term to the what? To the sixth term. -1, 34, and then what? 13. Okay. Can we continue here? I hope we can continue. All right. Now, the next one is, let me see, somebody has a question. Let me check. Oh, you are here now. Okay, Maxwell, please ask your question since you are here now. Maxwell, please ask your question. Oh, Maxwell is still not talking. Oh, he just left. Okay, let's continue. So now adding elements to a vector. So you see the case where we can address elements and all. We can add some elements to a vector. We can add some elements to a vector, and then we can also remove some elements from a vector. Like we can add elements to a row or a column. We can also remove elements from a row and a column too. So the next slide. So the next slide is, so we have what? A four element vector A1 is created. That's 2, 4, 7, and what 3. We have this. So now we say that A1 5 is to what 7. You realize that when you look at A1, please can we all see the screen that I'm sharing? I hope you can see the screen I'm sharing. Now, when you look at please let's understand this. When you look at A1 is just a what? It just has 4 terms as a rule. 1, 2, 3, 4. But then we are saying that MATLAB now call from the 5th term to the what? 7th term. If you do this, call fit to the 7th term, it can't give you an answer because it just consists of what? It just consists of 4 rules. So let's try that and see. So say we have,
so please, I was asking,
okay, go ahead.
I was asking if you have, let's say you have an indefinite spacing of the sequence. Like let's say you're trying to create like a Fibonacci sequence, or the spacing is given by an equation. Like let's say 4x plus 12, so determine the next term, something like that. Can you do it instead of using the even spacing?
Oh, for that one, you can write a code for it. You can just write a code for it because like that's more or less like a function. So we can write a code for it, and that's a different class altogether. We'll do that like Saturday day. Okay.
Okay, thank you very much.
So just remind me then. You can just write your question down. Yeah. So what if you want to select an element from a different row? We'll come there. Don't worry, we'll come there. We'll come there. So now we have, so let's go back to, okay, let's say day 2 underscore 2. So we have some elements 2, 3, 4, 5. Close it. So you see, we have a 4 term. Okay. So now we are saying that we should do day 2 underscore 2. Give me what fits to what 7th term. So you see, index exceeds what? The number of what? Array elements. Do you understand? So meaning the number of array elements is just 4. They are telling MATLAB that MATLAB should address from 5th to 7th. So in that case, it can't work out. So what do you do? So what you do is that if you want, so you see, so now what happens here is that what? We are supposed to do what? We are supposed to add what? We are supposed to add 1 is to 2 is to 5. Do you get it? Yeah. For what? 5th is to what? 7. So we are adding 3 additional elements as what? The 5th term to the what? To the 7th term of what? A1. That's what the equal to there stands for. So meaning that at this address, add it to it. Are we understanding what's going on? Yeah, that's one. Hello, are we understanding? Hello.
Yeah.
Yes.
Yeah.
Okay, we get it. All right. So you see that. Okay, great. So you see that for the constant, so you see that for this one, the best thing that you could use here is what? Linspace. To not to put yourself into any trouble. Because if you say that it should do from 5th to 7th right now, if you say do from 5th to 7th, and then the number of terms are more than, you realize that you can't really form the matrix. So let's try that. So you guys will have a look at it. So the same day 2 underscore 2. Do 5th to 7th term is equal to 5th to 7th term is equal to, say 2 is to 2, no, 2 is to negative 0.5 is to 0. You see, unable to perform assignments because the left and right sides have different number of elements. So you are saying that put 5th to 7th. 5th to 7th is just 3 terms. Then now, what you've placed over here is more than 3 terms. Do you get it? So everything must what? Correlate. So with this way, the best way to just add is to use the linspace. So the linspace, you can just specify the number of terms. Do you understand? So if you say 5th to 7th, 5th to 7th is like 2 terms, right? It's equal to what? Linspace.
Please, 5th to 7th will be 3 terms.
Oh, yes, yeah, thank you. 3 terms, thank you. So 2 is to what? 2 is to 0.5. Okay, 2 is to 0, comma what? Comma 3. Enter. So 2 underscore 2 5th to 7 is equal to linspace. Bracket 2 is to 0 is to 3 times.
Bruce, why are you using colon instead of comma for the link?
Thank you. Thanks for reminding me. Thank you for reminding me. Enter. So you see, when we try that, you see it worked out. So we have been able to add 2, 3, 4, 5, then 2, 1, and then what? 0. So that's the advantage of linspace. Linspace is able to just give you that thing. Like it gives you that freedom. 3 times. You just put it there quick. Then we can move on. Okay, now let's go back. Please, I hope we get it. Do. All right. So let's continue with this one. So the next one. So now it says that what? The 8th element is added to what? B2. So B8 is equal to what? 12. So then in that case, MATLAB will just do what? MATLAB will just assign 0 automatically to all those ones. Because remember, when let's say, okay, we'll get there. That's like equation, like that's equation there. I don't want to jump. We'll get there. Okay, let me explain now. Let me just explain now. Remember when you are solving, when you remember if you are doing those Gaussian elimination stuff, and then you have x1 plus x3 is equal to 5. And then you are asked to express them in a matrix form before you continue. You realize that x1 is 1. x2, there's no x2, so x2 is what? 0. Then x3 is also what? x3 is also 1. Do you get it? It's the same concept in this place. We don't have a 4th term, we don't have a 5th term, we don't have a 6th term, we don't have a 7th term, but then we need an 8th term. Do you get it? So just B2 of 8. B2 at the 8th, B2, the address 8th term is equal to what? 12. So meaning MATLAB will automatically just do what? Assign 0 from what? From the 4th to the what? From the 4th to the 7th term. I hope we get it. All right. Okay. So now adding elements to an existing vector. So let's say we have a lot of vectors. Okay, I think I even did that safe, but then I'll still go out. I'll still go back and do it. So let's say we have this vector. So we have 1, 2, 4, B, 7, 3, 6, then C, A, and B. So C, A, and B means that what? Join what? A and B together. Do you get it? So this is what we have. So let me go back to what I did. I'll open the charts back. Yes. So at the beginning of the class, I did this. Okay, I didn't put them in row form. I placed them as column form rather. Okay, but then it's still fine. Okay, then let me just create an example here myself. So let me use those same examples. So this is C1, C2, and what? C3, Control C. Let me just copy it. So this as a row. So now enter. So C is equal to open bracket C1, comma, C2, comma what? C3. And as I said at the beginning of the class, comma means that what? It's what? Flow. So you see it as flow. Then when you put a column means that what? Move it to the next line. So that's the whole point about this whole adding vector something. So C is equal to what? C1, column C2, column what? C3. In that case, enter. It will put it at this form. Or if you would just want it as one straight column, what you could do is that C1, C1, C2, and one C3, right? Then you do what? Then you transpose it. Then you have this. Please, do we get what's going on? Please, do we get what's going on? We understand?
Yeah.
Okay, that's fine. That's fine. So we are adding. So we are adding. So the same thing. It means that transpose A, transpose B, column them. So meaning that transpose A transpose now becomes a column. B transpose again becomes a column. Then when you put the semicolon sign there, it means that what? Move it to the what? Move it to the next line. So meaning when I have my 1, 2, 3, 4, perform the execution by putting the transpose of B right underneath of 4. So that's it. Someone asked the question. Person was like, so please, when specifically is the comma or semicolon or column used? Okay, so comma is used when you want to form a row. Semicolon is used when you want to form a column. And then columns are normally used in some commands that you want to execute. You understand? You have the notes, and then the more you practice or the more you use MATLAB, the more you understand. But then for now, we'll try some examples too, so we will get it better. Okay. So now I'm deleting elements for MATLAB. So when you want to delete elements for MATLAB, you see when we wanted to add, so when we wanted to add, we added by doing what? By putting is equal to what? Is equal to lane space, blah, 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 blah. But then this time when we want to delete, we'll just put a now bracket there. We just put a what? We just put a now bracket there. So, but then if you want to delete something, you can't delete something from something that's not there. So what do I mean? What I mean is that day2_2 is a matrix 2, 3, 4, and 5. Now I can't say MATLAB delete 5:7. Delete from the 5th term to the 7th term. It doesn't make sense. Do you understand what I'm saying? So we only delete based on what we have. Do you get it? Aha. So let's form something D2_3. So okay, let me give a wide range of lane. So let me give a wide range of values. Lane space, open brackets, 2, first term 2, last term 7, 0.3 as this one. Oh, hey, what's going on? We can't have 0.3 times. Let's think about. So it's equal to lane space 2, 7, 15. Okay, give me 15 terms so that I can demonstrate what that was. Great. So now I have this terms. I have a lot of terms here. Then I'll come and say, I want to delete an element too. Then I'll come and say day2_3, open bracket, 16. 16 is to 20. Then the now set. I put my now set there. Enter. So you can see what it says. Matrix index is out of range for what? For deletion. So meaning I can't delete out of range. I can't delete what is not there. But then when I put something like day2_3, open bracket, delete the 7th term. Delete the 7th term. I put my now bracket there. Enter. It has deleted the now bracket. So you see that it has what? It has 14 terms now. Do you get what I'm saying? You see that it has what? 14 terms now. So the 7th term is no longer there. What's the 7th term? 1, 2, 3, 4, 5, 6, 7. So you can see 4.1429 is not there again. So now let's say I say day2_3. Delete from, let's say, the 10th term to the 10th term. So let's say delete from the 8th term So the 15th term is equal to now. Enter. Hey, wait. Matrix index is out of range for deletion. Okay, now it's using this one. Now it's using this very one. Okay. Do you get why it says that matrix index is out of deletion? Do you get it? Do you get it? Do you guys understand why it's saying matrix index?
Yes,
Is it?
yes, please, we get it.
Yeah.
Why do you?
Yeah.
So you realize that when I altered this matrix, that's why it's good to be using variables. I should have, let's say, used a variable first, but then when I altered this one, the new matrix now became 14 terms. So meaning that it now has what? 14 what? Ranges. Do you get what I'm saying? Instead of the 15. But then if I used a variable initially, like I could have still altered a matrix with the same form. So altering it now to that blah, 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 to the 14th thing. I hope we get it now. All right. So next one. Hey, 211. Right now, no, 211. Hey. Time is running fast too. We've not done much. Slide 16. Okay, the next one. Creating matrices. So I think I've already explained this one. So this is done by typing elements row by row inside the square brackets. Then type the first row, separating the elements by spaces or commas. To type the next row, use a semicolon or press enter. So as you can see over here, you can also do a combination of commands. Yes,
please, I have a question.
Feel free.
So with this one, if let's say you have a matrix A and then it has 14 elements, and then you want to add a 15th element to it, and then you call that one matrix B. Have you seen? Is it that you are going to say if I'm not going to use variable,
is the matrix a row? Is the matrix a row matrix or a column matrix?
Row matrix, just like what we are working on right now.
Okay.
So to add the 15th term, I'll say A, then into brackets 15. Then I'll say it's equal to then the value I want to put
Good.
there.
Yes.
So in this case, I'm assigning that one to a variable B. So am I going to have two equal tos on the same line?
Are you going to have two equal tos? Okay, so let's try what you're talking about physically.
Okay.
Okay, so we have matrix A. So matrix A is equal to what? Is it a 14th term or 15th term one?
Let's say we have 14 term, and then we want to add the 15th term to it.
14 terms. So lane space, open bracket, 2, last term 9, 14 terms. Enter. Okay. We have 14 terms. Then we say matrix B is what? Matrix B is...
Matrix B. Let's say matrix B. We want to add a 15th term to matrix A, so that we call that one B.
So that we call that one matrix B, right? Okay. So let's say new variable, new V. So new V is, let's say 10, right? Then now we are supposed to add this 10 to this matrix to get a row. So there are two ways of doing it. One, matrix capital B is equal to open brackets, matrix A, comma. As I said, comma means what? Flow. New what? A. You get enter. So you can see the 10 is there now.
Yeah.
Do you get it? Do you understand?
Yes, please.
Or
yes, please.
The new way that we just learned, matrix A, open brackets, 15 is equal to what? 10. Do you understand?
Yeah. Yeah.
Do you get it?
Yes, please.
Do you understand? So if you want to name that variable, okay, I think I get your question. If you want to name it, I think it should be equal so that it will work out. Oh, incorrect use of assign a value to a variable. Okay. So then in that case, just go with a normal way. Matrix A, open brackets, 15 is equal to 10. So it means that we've altered matrix A now. Do you get what I'm saying? It means that we have altered matrix A. I'm coming, hold on, let me think about something small.
Sure.
It means we've altered matrix A. But I get what you're saying. Like you want to add a naming, like you want to add a variable to the thing straight away, right?
Without altering it.
Yeah, without
Just like the one you
altering.
did in the first one, but this time
Yeah,
I'm using the method that we just learned.
But then using the method that we just learned. Yeah, that's why I tried the double import, but it's not working out. Yeah, I get what you're saying. I get what you're saying. I get it. Get it. I've never thought about something like this before. So
Like
then,
this, okay.
so then I think then this is just the best way to go about it. Or we could also look for ways to. We are all learning the things together. So you could just do the matrix B is equal to the matrix A. Then you just add the new term to it. That's all.
Okay.
All right. Thank you.
All right. Sure. Thanks.
Okay.
All right. So for this one to creating matrix variables, I think I've already spoken about that. So more on creating matrix variables. So, okay, I'm coming now. I'm doing this one. All right. Because I want us to do the array operations too. That's why I'm checking the amount of slides that we have to do because we have to finish this today. Yeah. Okay. So more on creating of matrices. So you remember the slide that we did yesterday? We spoke about the fact that we have matrix functions like the zeros, the ones, and the i's. You remember that? You remember from yesterday's class? So you are come to use. Yeah. So you are come to use those functions here. So for zeros, zeros are just used for creating a zero matrix or a zero row. Then ones are just used for what? Creating what? A one rows or a one column. So the M there means row, N there means what? Column. So when I say zeros 2, 5, you will get there. Then ones 2, 5, that one is also there. Then I. So the I is just used for creating a square identity of a matrix of size n. So let's say I is 3. So I is 3 will just be what? A 3 by 3 matrix with 1. Do you understand? So now zeros 2, 5. So zeros 2, 5 means that what? Is from what? A second row, 2 rows, 5 columns of zeros. Math ones 3, 4. So ones 3, 4 is what? Ones 3, 4 is.
Yes, I've seen it.
1, 3, 4 is 3 rows, 4 ones.
All right.
Do you understand? Then I4. So I4 is just a square identity matrix. The diagonal term there is what? 1. Do you understand? Do we get what's going on? Okay, so let me go back to this one and demonstrate it. So zeros. So zeros 5, 7. Close the bracket. So you see, you need 5 zeros and 7. So this normally helps when you're inputting matrices. So let's say you have a matrix that is there, and then you know that, oh, one row is just 0. One particular row is just 0. So you can just pick that particular row there. Instead of now come to write 0, space 0, space 0, space 0, space 0, they just put the zeros there. Then let's say one particular row is ones. So ones open bracket 1, 3. As you can see, you get it. So when you say 5, 5 means create 5 rows with 7 columns. But then when you say 1, create 1 row with what? 1 row with 3 columns. So we'll do tutorial questions on all of these. Then we'll get them very well. I know now it looks more or less like it's looking like there's a lot of things passing through here. Like there's a lot of things passing through your eyes, but then we'll get there. So now, locating matrices. You see, the first one that we did was locating arrays or locating row and column vectors. But then for now, we are coming to locate matrices. So to locate matrices too, so for a matrix assigned to a variable A, that's A open brackets K, P. It refers that what? Address the matrix, say 2, what? 3. So let's go back to our MATLAB window.
I can't see your slides. So.
You are. Oh, sorry. Yeah, I didn't switch it. I'm sorry, I didn't switch it. Okay. So now, this is how you can see now. So let me go back. Okay, I think we've already passed this piece. So for a matrix assigned to a variable A open bracket K comma P, it refers to the elements in row K and what? Column what? P. Do we get what's going on? It means that what? We are supposed to do what? We are supposed to address the elements in what? Row K, column what? P. So let's try that. So I think I already have some metrics already. So I have some metrics here already. Matrix M. Matrix M is R1, R2, R3. So let's use that matrix. So enter. So now I want, so let's say we want the second row, the third element. So M open bracket 2, 3. Enter. What's the answer? -5. So do you get it? This is just used to call a what? An element. So you realize that, let's say you want to compute an operation. So let's say multiply the third term and the row 2, column 3 by the term in row 2, column 3 by say the term in row 3, column 2. So just M open bracket 2, 3 close bracket star what? M open bracket 3, what? 2. So that's -5 times 4. That's negative what? 20. You see it has come. So normally this is easy, but then when you have something like a 10 by 10 matrix, yeah, I'm coming. Let me open something from here for you guys. Yeah, I think it's this one. Good. Run. Hold on. Great. So you see, we have a 10 by 10 matrix here. Abby can see the matrix. So this was some people's mid-sem. A 10 by 10 matrix here. Please, I hope you can see the 10 by 10 matrix here. Then imagine they said, oh, locate, let's see, locate, say, oh.
Hello.
Oh.
Abdul Basit.
So you see that they'll say, oh, locate something. Let's say locate some term somewhere. How is it now that you're coming to look? Is it now that you're coming to look through with your eyes and then be counting? Now, where you can just perform a simple operation. So let's say, let's locate 5, 3. So 5, 3 is 0. Let's do it with our eyes. Okay, that's 0 indeed. Yeah. So let's get one with a number. Okay, 3, 10, 4, 10. So A open bracket 3, 4.
It becomes who am I dealing with?
So you see, yeah.
Okay.
All right.
Someone made a payment. I don't want a situation where they will come and there are two different things. This one is saying I did this.
Okay. So now, so you see over here, so we can also change elements too in the matrix. So let's say I want to change the elements from say, okay, so let's go back to our matrix. So we are matrix A here. So our matrix. Okay, so let's continue. So we want to, so let's say we have our matrix A here, and then we want to change we realize that, oh, we realize that the fifth row and then the third column had an element what? 0. So now we want to change that element 0 to what? 1.2. Do you get it? So we can just do what? We can just do it like this. So that's matrix A open bracket 5,3, like the way we added elements before. See the way we added elements before? No? We can just do same over here by addressing the particular matrix, then putting the value there. So say 1.2, enter. So yeah, we can see the 1.2 there now. We can see the 1.2 there now. Do you get it? So I'm thinking, so let's try this. So let's say we want to change some zeros here. So let's say we want to change some values. So let's say we want to change, some of you should give me like places where we can change in this 10 by 10 matrix so that we'll do all at once. I want to see if it will work all at once. Let's try that. Can people give me a place where we can change?
From 6, the row 6, we can change column 1 to column 4. I mean column 2 to column 4.
We can change row 6, column 2 to what? Column 4.
Column
right?
4, yeah.
Okay. So A6, what? 2. Right? From column 2 to column 4. So I'm thinking about this. Hold on, let me. Yeah. Column 2. I want to see if it will work. I want to try and join everything together and see if it will work. Then A open bracket 6, 4. Say from column 2 to 4.
You can do column 2 to 4.
Column 2 to 4. Okay, that's fine. Then I'll close the brackets now. So meaning 3 terms, right? So lane space open bracket 2, last term 3. Give me 3 terms. Let me see. So assigning the function, the output to this expression is not supported. So let's go with the normal way. Let's try the normal way. So the normal way to do is to go with do them one by one. That's a lot of work there. MATLAB needs a lot of updates. So you can do the comma. Let's try this to see if it will work. It's not in the slide though, but it just came into mind. Let's try it and see if it will work. Too many input arguments. So it means you have to do it one by one. You have to do it one by one. So meaning you have to change the whole thing one by one. Do you get what I'm saying? Hello? Do you guys understand what's going on? Do some of you understand? You see, I wanted to change let's say all of them at a go. But then MATLAB is telling me that too many output arguments. It means that it means that you have to do it one by one. So some of these things. So that's why you take your time and let's say you write a matrix as rows first. You write them as rows first before you come and do what? Before you come and say. So let me give you an example. So you see now changing the thing is difficult. So let's say lane space 2, 3, 4. Suppress this. R2 is equal to lane space 3, 5, 4. Okay, semicolon. Then now R is equal to what? R1, semicolon, what? R2. Close it. Our matrix comes. Do you understand? You see that our matrix has come. So you see, MATLAB is saying that we can't change 2 of them at a go. What we can do is that what? We can change 1, 1. Do you get what I'm saying? But then the beauty of this is that when you do it this way in your script file, so let's open a script file now. Let me just copy this, open a script file here quickly. Then I come and type it here. So for a script file, so let me explain this quickly. I say, okay, we can do it like this, okay. So you see that for a script file, what happens here is that what? You can have the chance to edit. So when we run, I have to, it's a long process. It's too long. Coming to save there is too long. Let's continue. So I think somebody placed something in the chat that we can do it like this. So let's try it that way. Let's try it that way. So it said A open bracket 6, 2 is to 4. Yes, that makes sense. 2 is to 4. Yeah, that's true. Makes a lot of sense. It's equal to lane space open bracket 2, 3, 3. Yeah, makes a lot of sense. Yeah, a lot. Yeah. Yeah, thank you very much. Makes a lot of sense though. So you can see that we've changed it over there. Yeah, the command was not right. Okay, that's fine. So we can try something like, we can see the ninth rule to the, the ninth rule, I think from the 5th term. Yeah, so the ninth rule from the 5th term, we can change all of them too. From the 5th term to the 10th term. You can change all of them with what? Lane space, open bracket, 4, 25, what? 5 terms. Enter. Oh, to perform assignment. 5 to 6 is how many?
It will be 6 terms actually.
6 terms, okay. Yeah. All right. Right. Yeah. So we can continue now. Please, I hope you get what's going on. Okay. So now, okay, yeah, it was here. So addressing matrices. So A colon comma n refers to the elements in all rows of column n of a matrix. Then n comma that refers to all elements in all the columns of row n of that. So what we just did, A colon comma m is to n refers to what? The elements in all the rows between m and n of the matrix A. So let's try this once. So let's use this same 10 by 10 matrix. So from the 10 by 10 matrix above, so we want to call, let's say, say row 3. Now, comma is to that, I should presume. Enter. Good. So now we say that, now call the third row of this matrix. Do you understand? So this is what we get. So when the value is first, it means you are calling a row. When the value is last, it means you are calling a what? It means you are calling a column. So let's try the same thing again. So call open bracket, comma, it's column, comma, 4. So column, comma, 4. So it means I call the what? Call the fourth column. Yeah, from this matrix. Okay.
I'm just afraid that Saturday you might have that class alone.
Then all of this, we can try all of them. So m is to n, comma p is to q refers to all the elements in rows m to n through columns p to q. Yeah, so we can add up stuff like that. So you realize that with the matrices, there are a lot of commands there. There are a lot of commands that you can execute. It's up if you know them or not. So you see, like the one that the guy just shared in the chat with us. Yeah, you realize that something like that is not. You realize that something like that is not here. It's not in the slide do. But there's something that just entered my mind that can we do something like that? Yeah. So okay, these are all examples. Okay, so adding elements to a matrix. I think we already did that. Yeah, I think we already did that. So deleting elements to be the same thing. All right. So now array operations. Please, do we understand? Please, do we understand? Please, do we get it?
Yes, please, you get it.
We understand. Okay, I'm coming.
We are okay.
We are okay. All right. Have they sent the attendance sheet or something? They've not sent it. All right. And NK, please text Caleb so that he would send them. Please text
All
Caleb.
right.
Yeah. Please text Caleb so that he will send them. Okay. So now MATLAB has many inbuilt functions for managing and arranging arrays. Can we go over the adding elements? Okay, let's go over the adding of the elements. Okay. So now, we said when we want to add elements, all we need to do is that what? We need to address wherever we want to add, and then put, and then what we want to add to that address. Do you get it? So we have this 10 by 10 matrix here. We have this 10 by 10 matrix here, E. The 10 by 10 matrix is here, E. And then now we said that, oh, we call the address 5, 3. Realize that the 5 and the fifth row, the third column, the address is what? 0. Okay, so now we are saying that now change the fifth row, the element in the fifth row of the what? Of the third element to what? 1.2. So when we did that, we had our 1.2 here. Now we are also saying that we can also do the same thing by what? We can also do the same thing by changing, like, let's say, by changing a whole row. So let's say row 6, column 2 to 4. Now we are supposed to change 3 terms there. And by changing it, what do we want to change it to? We don't know the exact term, but then we want our first term to be 3, want our last term to be 3, with the number of terms being what? 3. So after we did that, then we did what? We had this. Do you understand? And I also print today's command window and post it on the page, because there are some things that we spoke about and then we tried which are not there, so that you can also go through too. Yeah. So let's continue with the metrics.
Yeah, that would be great.
Okay. So the array operations. So for the array operations, MATLAB has many inbuilt functions. So let me open yesterday's slide set so that you will see some of them, so that those who are not here could see some of them. Yeah, can we see them? Can we see them? Hello, can we see yesterday's slide?
Yeah, sure.
Yeah, we can see.
You can see, okay. So you see the matrix function. So you see there was i's, there was zeros, there was ones, there's extract diagonal of a matrix or create diagonal upper triangular matrix, lower triangular matrix, randomly generated matrix. And I said they were in 2 forms, right? Remember I said they were in 2 categories. One is used in metric building functions, and the other is used in what? And the other is just used to operate them. So for size of matrix, determinant of matrix, inverse of matrix, rank of matrix, reduced row echelon form, eigenvalues and eigenvectors, characteristic polynomial, all of those things, they are all there. You can use all of MATLAB to do what? You can use all of MATLAB to execute some of these things. Oh no, this is here. Great. So you see now, you can get the diagonal, you can get the length. As the length means it returns the number of elements in the vector A. You can get the size to give you the size of the shape. Give you can reshape it. Hey, who's this one is causing a lot of havoc here? All right, so you can reshape it too. Okay, so now you come to perform some operations. So you can do addition. So one thing about doing this addition, doing addition and subtraction with matrices is that they must be of the same length. Do you get what I'm saying? Sorry, not length. They must be of the same shape. So meaning if it's a 2 by 3, it must be able to also work with the what? With a 2 by 3. So let's try this. All right. So let's try this. Oh. Okay, so when we have row 1, you say we have A1 to be, okay, let's use namespace. This space is very nice. Namespace, open bracket, 2, 3, 4 terms. Oh, what's happening? Yeah, let me just go and mute everybody safe. I'm coming. Let me stop sharing my screen for now. Then let me mute everybody. All right. Okay. So now I want the matrix. So lean space 2,3 as my first 2, 3, 4 terms. So meaning to be a 4 by something matrix. So meaning to be a matrix of 4 columns. So lean space, I can just form one quickly here. Lean space, open bracket 5, 2, 4 again. Then my last term, lean space again, open bracket 1, 5, 4. Perfect. Close the bracket, enter. Oh, how? How are they not consistent? I'm going to use this thing. Damn.
Blues, I think
Yeah, I've seen it. Don't worry.
Okay, sure.
There was one semicolon here and there was one comma here. I've seen it. Thanks, man. So now we have matrix A to be this. Then we have A2. A2 is so let's say A2 is lean space 2, 3, 4, comma, so semicolon, lean space, open bracket 5, 2, 4 again. Close it. Okay. Now I say A3 is equal to A1 minus A2. Let's see what will happen. So you see, arrays have incompatible sizes for this operation. So meaning that what? They must what? So meaning that they must be of the same size before you can perform the what? Before you can perform the operation. So try something like A3 again. So A3 again is equal to what? A1 plus A2. So meaning that the matrix must be of the same size before you do what? Before you can add up or something. Okay. So let's go back. So addition and subtraction, we know how to do them. Then let me not waste time here. There are more things to waste time on. Okay, now multiplication. So when you want to multiply matrix, multiplying matrix is executed by what? Star. So one thing, when you want to multiply matrix, one thing is that the number of columns in the first matrix must be equal to what? Must be equal to the number of rows in the what? In the second matrix. That's the only way that we can do what? We can multiply them. So looking at this one. So for this one like this, somebody might not know the size of this matrix. So you don't know the size of it, just come, size, open bracket, A1. It will give you the size. So that's 3 rows for this one. Then size, open bracket. Somebody doesn't know the size for A2. So let's say the person is writing a program that the person cannot execute them. A2. So it's what? 2, what? 4. So what did I see? So I said that what? The number of columns for the what? The number of columns for which one? The number of columns for the first matrix must be equal to the what? Must be equal to the number of rows for the what? Must be equal to the number of rows for the second matrix. So let's try it and see if it will work. So A3 in that case is equal to A1 star A2. As you can see, you see it didn't work. The columns here is what? 4. The rows here is what? 2. So it can't work. Do you get it? So it means that what? They must be what? They must be of the same what? They must be of the same size before you can do them. Okay. Then now, array operations. So for array operations, we have 2 types of array operations. We have the left division and then we have the what? We have the right division. So now left division is used to solve matrix equation. That's AB is equal to AX is equal to B, where X and B are column vectors. So now the solution for such would be what? The inverse of what? B over what? The inverse of B over, the inverse of A over, the inverse of A times B. And this can be written as A left divided by B. Okay. So there's also right division too. So for right division too, it's used to solve X is equal to D, where X and D are what? Row vectors. So in that case, X will be equal to what? X will be equal to D right divided by what? C. So now we are come to solve this system of linear equations. We are come to use two ways. We are come to use the way of what? Come to use the way of the left division approach, and come to use the right division approach, and then I come to see there. And then we'll use which other method? Which other method we use? And then we'll use the inverse method too. Let me just kill all the birds with one stone. Yes. So the inverse method too. All right. So now we said for left divide, when we want to do left divide, we said we have to do what? We said we have to express X and then Y as what? We have to express X and B as what? As columns, right? Okay. So give me the matrix. Can somebody say the matrix for me? So what's the matrix? The matrix A is what? So if you have to express 2x, 5y, 7z, 3x, negative 6y, 2, 9, negative 3y, whatever, how we express it in the matrix form? Can somebody give it to me as a matrix quickly?
-2.
-2.
Okay.
In a row for -2, 5, 7.
5, 7. Okay.
Yes.
Next
Then
row.
the next row, 3, 6, 2.
3, 6, 2. Okay.
The next row, 9, 3, 8.
9, 3, what?
Negative
8. All right.
6.
Hello, please, you're saying something. Oh, somebody was saying something.
Yes. Correct. Negative
Yeah, 3
6
minus
and
6.
Negative 6. So
It's 3 what?
Minus 6, 2.
3 minus 6, 2. Okay. So the
The
first
last
way,
one is 9 minus 3,
negative
8.
6, not positive 6.
so the last one is 3 minus 3 what? 8.
8.
3 minus 3, 8. All right. 3 minus 3, 8. That's fine. Okay. Okay. Then now, and now when we are using left divide approach, we said
The last
X,
one is 9 minus 3, 8.
oh, let me check this thing myself. 9 minus 3, 8.
9 minus 3, 8.
Oh, okay. That's true. 9 minus 3, 8.
9 minus 3,
3, 8. Yeah, I've seen it. 9 minus 3, 8. Enter. Okay, that's fine. And then for left, 9 minus 3, 8, right? Yes, I've seen it. So now for left divide approach, we said that for left divide approach, what happens is that what? We are supposed to do what? We are supposed to express the X part as a what? As a column, and then the B part as also what? As a column. Do you understand what I'm saying? Aha, I'm coming. Oh, remember math? Remember math? When you have to do Gaussian elimination, what happens is that you have to express it one form. That's the augmented matrix, and then your result matrix, or however they used to call that one. I think the first one was called coefficient matrix or something. Then that's the one that you augment to get your B or something. So that's what. Then you have your B part, and then the B part is the result. Do you understand? So now they are saying that. Okay. So you realize that they are saying that X, the X part, which is the X part, which is what we are looking for. Let's see, E, F, and G. E, F, and G must be what? E, F, and G must be in columns. And then B must also be what? B must also be in column. Do you get what I'm saying? Aha. So then in that case, can someone give me the B? So it means that our B must be what? Our B must be in a column form. So can someone give me this one for B?
It's going to be 17.5 colon.
17.5 colon.
40.6 colon. 56.2.
40.6 semicolon What?
56.2.
56.2. Oh, I'm sure it's 56.2. Yeah, 56.2. I think it was negative 17.5 for the first. I think it was negative 17.5. Okay. Yeah, it was negative 17.5. And negative 17.5. Okay. So now we have B as a column. Then what they are saying is that if we want to get the answer for X, what we can do is that we can do what? The inverse of A times what? Times B. Or what we could also do was that we could also do A left divide what? Left divide B. Or isn't that what we, or isn't that it? So we could also do what? A left divide what?
B. Yes.
We could also do A left divide B, right? Right?
Yeah.
Okay. So you see that they are the same thing. So there is this thing. So in MATLAB, normally when you are doing this operation something, they'll restrict you. That use left division approach, use right division approach, or you could also use what? Or you could also use the inverse approach. So now when we are doing for the right division approach, so this is the left division approach. Oh, I should have written it there. X is equal to A slash B left division approach. Left division approach. Then now, when we want to do the right divide approach, for the right divide approach, what happens is that what? We have to express B as a what? We have to express B as a what? As a row. Do you understand? Okay, so now B becomes a row. So let me just do small b. Small b is equal to what? Capital B transpose. That's all. So now it becomes a row. And then they are saying that for us to get X, what does it mean? It means that we have to do what? X is equal to what? B right divided by what? A. And now, isn't that what we are supposed to do? For the right divided up? Yeah. Right division approach. Yes. All right. So for the right division approach, yeah, right division approach. Enter. Okay. So you realize that we get what? Two different answers. Do you get what I'm saying? You realize that what? Wait, oh, did I use? Yeah, you realize that we get two different answers. That's one thing about the left division approach and then the right division approach. Normally, you don't get the same answers. Most of the times I've tried them, never get the same answers. Okay. So please, I hope we can continue now. Yeah. Okay.
Blues.
Yes, boss.
And please, one thing I realized over here is that with the right division, when I used transpose of A, so small b divided by A transpose, I got the same thing. But then this one in a row form. Yeah.
Was B a row?
Yes, just like what you've done now. But then I made the A transpose.
You made an A transpose too.
Yeah.
Okay, then in that case, we can have it that way. Okay, then in that case, we can have it that way too. So then it means that then in that case, when you want to do the right division approach, it means that when you want to do the right division approach to get the same answer, that's for the right division approach to get the same answer. What you have to do is that you have to also transpose A too. But when you only transpose B, you don't get the same thing. To get the same answer. So normally I advise that don't use the right division approach, just use left division. But when you are restricted to do that, to get the same answer as inverse. Use the what? You have to transpose the A2. You have to transpose the A2. All right. So let me go back to share my screen. So transpose, that works. Okay. Now, element by element operation. Element by element operation. You realize something in MATLAB. That in MATLAB, when you want to multiply, let's say you want to let's say you have A is equal to okay, let's use that matrix A now. So let's call A. So A enter call. We've called that A is -2, 5, 7, 3, -6, 2, 9, -3, 8. Now we say that we want to get hold on. Now we've called our A, right? So now we want to get, now I want to do element by element multiplication. What do I mean by element by element operation? Which means that -2 divided by -2, 5 divided by what? 5, 7 divided by what? 7, 3 divided by what? 3, -6 divided by -6. Like you pick an element and then you do what? So if I say, let's say A element by element multiply A, look at what we'll get. It multiplies each element at each position will be multiplied by each element at that same position. So -2 squared, 4, 5, 25, 7, 49, 3, 9, -6, 36, 2, 4, 9, 81, -3, 9, that's that. So let's do it this way. So let's also do A, let's divide E. So you see 1, 1, 1, 1, 1. Do you understand? Do you get it? That's the element by element something. So let's say we have our A, we have B. So let me just create a matrix B right now. So B is okay. No, I don't want us to use zeros. I don't want us to use zeros. Zeros be too much. Let me just change this and make this link space. Space to 9, 7, 3. Oh, yeah, I mean that. Whoosh. Please hold on. I don't want to retype everything again. Hey, let me just type it quickly. Okay. Okay, so now we have B and then we have A. We have B and then we have A. So let's perform element by element something. So let's say A element by element multiplication of B. So as you can see, this is A. These are A. So A is what? Minus 2 times 4. That's minus 8. 5.5 times 5. 27.5. Like that, like that, like that. That's what the element by element does. So when you want to do element by element division, so you could do element by element exponents too. You have this. You could do element by element division. This left divide, right? I think this right divide rather. So infinity. So you see, we have everything there. That's what the element by element does. Okay. So for element by element, whatever operation that you want to perform, you need to do what? You need to add a dot to the operation. So dot multiplication, dot exponent, dot division, dot left division. Okay, so this just explaining it. This is another example. Okay, so now built-in functions for analyzing arrays. So there's mean. So what the mean does is that if A is a vector, it just returns the mean value of the vector. Note, there's a difference between a vector and a matrix. I explained that. There's a difference between what? A vector and a matrix. I explained that. A vector, you could have a row vector or you could have a column vector. Do you understand? They are two different things. Don't do mean of. So let's try it and see. So that, because sometimes you just see it and it's like people don't really get it, but when you do it, it sticks. So let's say mean. So mean open bracket A. No, I mean this. So you see what it has done? It has rather calculated the mean for each of the words, for each of the columns. Do you understand what I'm saying? It didn't just give us the actual mean for like each one. So what we do is that we can perform it on what? We can perform it on rows. Great. Then we have maximum, we have minimum, we have sum, sort, median, standard deviation, determinant. So for determinant, you can use some metrics, dot product, cross product, inverse, and whatsoever. So over here, you could also, so you see how I was struggling to get matrices. I could just put an issue over there that, oh, MATLAB generate a random matrix for me. So you have 3 commands that we could execute: rand, n, and then what? Rand I. So rand means that generate a single random number between 0 and 1. So generate, so you see all of them are there. So generate something within what? Generate something within this set of, like generate this matrix for me, but then it should be within what? 0 and 1. So when you get the notes, you can just go through all of it and then we can do that. Please, do we have any questions or something before we go to our class activity? We try our class activity and then we talk about yesterday's assignment and then we will close. I think we should be closing by 3:30. What do you guys think? What do you guys think? Is that too much? Is that asking too much time?
Of
Is
course,
okay?
I think because Clinton is starting his class in some few minutes.
And some of you have to join that class.
You Bob.
Oh, okay. Tell him that I said he should start his class at 3:30. You can't fight his video, but tell him that I said he should start his class at 3:30.
He already sent the link and then some of us have joined already.
Hey,
Yeah.
some of you too are irate. Why? You guys are too irate. You guys are too irate. Okay. That's fine. I'm coming. So what do we do now? Okay, tomorrow
we can quickly go through the class activity for today.
The class, you get, so what about the assignments? Because assignments is also necessary. Because it be like squad no sit up the assignments, or squad sit up. Yeah, so let me resend the, let me resend the class. Okay, let's go to the class activity group. Because if I'll give assignments, this assignment is very easy for the class activity is very easy for an assignment to do. Okay, So let's go through the class activity. Let's go through the class activity. Have we downloaded it? Have we been able to download the class activity? Have we been able to download the class activity?
Yes, we have.
We have downloaded it. Okay, I'm coming. Let me open mine. Let's do that quickly then. I think, okay, then the best I'll do is that I will just more or less like do voice notes of everybody's assignment and put it on the page on what you're supposed to change and all. Yeah. I said the assignment, could we get the answers? Oh, why not? Are there deadlines to submission of assignment? No, they are not deadline submission of assignment. You can just do them. Like they're just, it's a boot camp. It's not a classroom, Charlie. It's not a class, it's just a boot camp. So let's try the activity. Yeah, so I'll send the assignments. Yeah, I'll send the assignments. Okay, so this is the activity. So it said kindly perform create a diary section called class example underscore activity 2, in which you should perform the following exercises using MATLAB commands. Okay, so this is it. I'm coming. Hold on. So can someone give me the metrics? Okay, let me download this. Let me print out this metrics first. So, now, can someone give me this one? Can someone give me the metrics?
2
2
9 0 0.
So okay, let me clear the workspace too for now. Hold on, let me clear the workspace. We can start fresh. Play. Okay, so he said matrix A is what? 2 what? Give me row by row. 2 9 what?
2 9 0 0.
0 0.
Next row 0 4
0 4
1 4
1 4. Okay, next
7 5
7
5
5
1
5 1. Then the next one
7 8 7 4
7 8 7 4. Okay. Okay, enter. Now the next one, the small e. Okay, there's a small
just,
b. Yeah, there's a small a too. Small a is just the rule of what?
3
3
negative 2
negative 2
4
4
negative 5.
negative 5. All right. Okay, that's fine. And then the b. The b is
the column.
It's a column.
Yes.
So column of
negative 1
negative 1
6
6
0
0
9.
9. Okay, perfect. All right. All right. Can you see my screen now? Can you see my MATLAB screen? I hope you can see the MATLAB screen.
Yes, please.
Okay.
Yeah.
Okay. So what does the first example say? So the first example says that we should calculate the following. A dot B. So A dot B is more or less like what? A times B, right? Perfect. So now A times B. So will A times B source? Let me ask, will A times B source? Do we think A times B will source? You can see A is a 4 by 4 matrix. B is a what? 1 by 4 matrix, right? So will this source? So try 1. Try 1 says that we should do what? A times what? B. Great. Then the next one. The next one says that we should do A plus 4. So A plus 4. So try 2. Try 2 says A plus what? 4. So meaning that for each term of small a, add what? 4 to it. I hope you are following. Okay. Then the next one, B dot A. So try 3. Try 3 says that what? B times what? A. Do we think B times A will work out? Do we think B times A will work out? Because B is a what? B is a 4x1 matrix. And then small a is a what? Small a is a 1x4 matrix. So meaning the what? Oh, hold on. B is a 4x1 matrix. Yeah, 4x1. Perfect. And then A is also a 1x4. Yes. So then we'll end up generating a 4x4 matrix. That's what we have here. And then D says that what? D says A times B transpose. Try 4. That's what? A times what? Hey, somebody is asking a question. Okay. Is that what? A times what? B transpose. So you see, it can't work out. Why can't it work out? It can't work out because before we can perform something like that, we have to do what? Element by element. Do you get what I'm saying? Because we have 2 rows. Then we want to multiply them. If we want to multiply them, for that to work out, we have to do what? Element by what? Element. So that will be equal to A dot star what? B transpose. Enter. So we have our answer for that. So for the last one, we can do that one. Now, explain any differences between the answers that MATLAB gave when you type A by A. So A by A is just E squared, right? So if we type A, capital A times capital E, square matrix by a square matrix will do what? It will work out. If we do A to the power 2, that one will also do what? It will also work out. But then when we do A dot to the power 2, that one, it means that what? It means that square each of the elements, square each one of them by each one of them. Do you get it? So then in that case, it's what? 481, 0, 0, then 0, 16, 1, 16. See, I didn't fill the attendance sheet. Oh, you can just check through and fill it. Okay. So then 49, 25, 25, whatever. Then the next one, what's the command that isolates the submatrix of that consists of the second to the third rows of matrix A? So which command can we use that would isolate the submatrix that would consist of the second to the third rows of A? Which command can we use? Please, which command can we use? We just learned something. So which command can we use? In case probably you want to. Oh, the Google form is not the response again. Oh,
I think we can use.
Hold on, I'll address the Google form issue. You said we can use what?
We can use A bracket 1. Okay, we are doing 2 to 3. So A bracket 2 colon 3, comma, then we bring a colon, then we close it.
Okay. We said we can use what? A open bracket what?
A open bracket 2 colon 3.
A
then
open bracket 2 colon 3, comma what?
3, colon.
Comma, colon.
Yeah, then we close it.
Then you close it.
I think this should work.
It should work. Yeah. It should work out. It should work out. Yes. That's great. That's perfect. It means that what? We are extracting. It means that we are extracting row 2 and then row 3. The whole of those rows. So 2 is to 3. 2 is to 3 means 2 through to 3 of the rows. Do we understand? The video will be available so that if you want to watch it again, why not? So there. And then the last question. The last question says solve the linear system A of x is equal to B. For x, check your multiplication. So for this one, we can use the left divide approach when we do the left divide approach. So for left divide approach, B is already a column, A is already a matrix. So for the inverse approach, inverse approach, we could do capital X is equal to what? It's equal to A left divided by what? B, right? No, sorry, for the inverse approach, inverse of A times what? Times B, right? Okay, so we have this as the answers. Inverse of A left divide B. Okay. Okay, that's fine. Then the next one. So the next one, when we want to do the left divide one, so what would be the formula or what would be the command that we have to execute for the left divide? What would be the compound that we have to execute? What will be the command that we have to execute? Is somebody on the call? Can you hear me? Which command?
I can hear you.
Yeah, which command do we have to execute for the left divide approach?
Hello.
Yeah, I'm here. I want to get to try it. Yeah, go ahead.
I think it will be X equals the A dot left divide B also.
A dot left divide B. It's just it's just A left divide B. Don't worry. It's just A left divide B. Great. There's no dots. Just A left divide B. All right. Then for the right divide approach. So for the right divide approach, what happens is that what? We have to do what? To get the same answers, we have to transpose what? We have to transpose A and B. We have to make B as a row. Do you understand what I'm saying? And then A, we have to do what? We have to transpose A too. So in that case, what will X be? In that case, X will be what? How will we get X in that case? In that case, how will we get X? So in that case, it will be B. So in that case, it will be B transpose right divided by A transpose, enter. So you see, we've gotten the same thing. Yeah. So yeah, thank you very much for joining today's class. Let me just print this one too. After we are done, we can have this. We'll have it. So let me just save it. How should I save it safe? So day 2 class activity results. Okay, so that's it for today. And please, do we have any questions? Please, do we have any questions? Yeah, tomorrow we'll start on time. Someone asked, please, the link. Okay, how many of you have not? What's the name? How many of you have not registered? You didn't fill the attendance form. Like, just type your name over here. Just type your name here. Like, if you've not registered, just type your name here so that I can copy it and give it to them that, oh, these people said they didn't. Okay, let's go on. So just Kelvin and okay. Hold on, let me just copy this. Anybody else? Anybody else? Okay, nobody else. All right, that's fine. So thank you all for joining today's meeting. So your assignment will be there, and then I'll send the answers for the last assignment so that we can go through and all. Yeah. Thank you very much for your time. Thank you very, very much. But before we go, let's pray, then we'll go. Yeah. All right. So our Heavenly Father, the slides. Oh, I'll send all of them. Don't worry. I'll do that every day. The video. I'll send the slides. Like, it's my work. So don't worry. I'll do it. Okay. So let's pray. Yeah. Father, we thank you so much for such an opportunity to meet. We thank you for the knowledge that you've impacted into our lives. Thank you for the wisdom that we've gained today. Father, we pray that we'll be consistent with this. We'll get the energy to continue tomorrow, because it's not just about the start, it's about the finishing. This is many more we ask in Jesus Christ, I've prayed. Amen. Amen. The recorded video. Oh, I'll send everything. Don't worry. It's my work. I'm supposed to do it, so I'll do it. Don't worry. Thank you all for your time, and thank you all for joining. So I'm ending the meeting. Bye.